All right. Hello. Here we are wrapping up chapter 4. Okay, so 4.7. This is part 1. Um, take notes and make sure you are checking in for attendance. 4.7. Inverse trig functions. Okay, so just first, for any of you guys that plan on being math majors, some little technical definitions here at the beginning. Okay, so function. We're going to take a look at what it means to be a function, what it means to be an inverse, and what it means to be a one-to-one function. Okay. So a function, and we have the notation that looks like this. So it is basically a rule or correspondence that pairs each element of the domain and usually we use x as the variable to represent values from the domain. Okay, so a rule or correspondence that pairs each element of the domain with exactly one value or one element from the range. So if you have taken any math classes before, maybe you had your instructor talk about the definition of a function and maybe they give you some examples. Okay, so like this would be a function and this is not a function. So basically, every x value gets paired with a y value, right? If we're using x and y to represent the domain and range respectively. And so every x value has to get paired up with exactly one y value, not two and not none. Okay, so it has to, like if 3 is in the domain, 3 has to get paired up with a y value. And it can only get paired up with one y value. So you can never have the 0.32 and also 3,1. Okay, so 3 can only hook up once. Okay. Um, and you can't have like 3 just sitting there waiting. Okay, so 3 can't be there not paired up with a y value. Okay, so if every x value gets paired up with only one y value, then you have a function. Okay. Uh, when we talk about the inverse, so you probably have talked about inverses before. This is the notation. Okay, so that's not like an exponent -1. That is our symbol for inverse. Okay, and here the inverse is a function that interchanges the coordinates in each ordered pair of another function. Okay, so it switches the x and the y. So if 3, 2 is a point or a coordinate from the function f of x, then 2, 3 would be a coordinate in the inverse function. Okay, so it turns out not all functions have inverses. It turns out that only functions that are one-to-one have inverses. So one-to-one functions. So what are those? Okay, so here, if you remember, maybe you were taught that, uh, the graph of a function passes the vertical line test, right? If you draw a vertical line, it'll only cross the graph once, right? Okay, so functions pass the vertical line test. Okay, and so first it needs to be a function, right? So it needs to pass the vertical line test to be a function. And then in order for it to be a one-to-one function, it needs to pass the horizontal line test. So a one-to-one function has to pass both the vertical line test and the horizontal line test. Okay, so one-to-one functions pass the horizontal line test. And what that's really saying is that every x value in the domain um, gets paired up with a y value, exactly one y value. But here's the deal. If that y value is already paired up with an x value, then no other x value can be paired up with that y value. Okay, so you'll see it like with like a parabola, right? Like the function y equals x squared. Okay, so if you plug in 1, you get 1. If you plug in -1, you also get 1. That's a big no-no for one-to-one. If 1 is already paired up with 1, -1 has to go find another y value. Okay? All right, so if f of x is a one-to-one, then f inverse exists. Okay? If it's not one-to-one, then there is no inverse. Okay? So this is kind of an important idea because here in this section, we're talking about inverse trig functions, right? Inverse trig functions. Well, it needs to be a one-to-one function in order for the inverse to exist, right? And it's going to be a one-to-one function if it passes both the vertical line test and the horizontal line test, okay? But let's take a look here. We have a problem. Okay, if I take a look at the graph of y equals sine x, right? We know that from 0 to 2 pi, right? So let's go 0 to 2 pi, right? We know that we get this graph, right? We had 0, 0, 0, halfway between 1, halfway between -1, right? We get this graph, right? And and that's just for one cycle, right? If we go the full domain, this graph repeats itself forever, right? And here, let me do 3 cycles, and then we'll see what happens. Okay, so we get 0, 0, 0, halfway between 1, halfway between -1. Okay, so we have that, and then same thing here. It keeps repeating itself. And so we have 0, 0, 0, halfway between 1, halfway between -1, right? And so we can already see that I don't even have to do 3 cycles. And this, we know that sine x goes on forever and ever and ever that way, and then it goes on forever and ever that way. But even if I just looked at the one cycle from 0 to 2 pi, it doesn't pass the horizontal line test. So we can already see that the sine function is not a one-to-one function, right? And if it's not one-to-one, then the inverse doesn't exist, right? Yet this this section is called inverse trig functions. So they must exist. So how? Okay. And the same thing is true for cosine. And let me do the graph of cosine so we can also look at that. Okay. And we'll just look at these together. All right. So 0, 2 pi. And we know that here it's 1 and 1, halfway between -1, 0, and 0, right? And so we know that it does this, right? And if I continue for another cycle, I go all the way to 4 pi, right? Then I get this graph here. But I mean, just looking at one cycle of cosine, we can already see it's not a one-to-one function as well, right? And I can go like that. And if I go this way, -2 pi, right? Okay, so we see that both of these are not one-to-one. Okay, so let's write that down. Neither one is a one-to-one function because they don't pass the horizontal line test. Okay, so how do we get these inverse trig functions? Well, if we restrict the domain. So neither one is a one-to-one function unless we restrict the domain. And so that's what we do here. So if we only look at a portion of the graph, that would make it one-to-one. Let's take a look here. So like here we have one sine wave, right? Okay, so there are many places that we can start and then stop, and then it would pass the horizontal line test, right? So like definitely not there. So maybe like here to here, right? Okay, so what happens is it actually stops. Let me do this in purple. So it stops right here at pi over 2, and it starts here at -pi/2, so that we only look at this part of the graph. And if we look at only this part of the graph from -pi/2 to pi/2, that purple part, right? That purple part will pass the horizontal line test, right? And then same thing here with the cosine graph. If we restrict it to just a piece of the graph, so they here actually restrict it from here 0 to pi. Okay, so they look at here all the way to here, and we see that this part of the graph, if we only focus on that, it too will pass the horizontal line test. Like right now, if I draw a horizontal line through cosine, it passes so many parts of the graph. But if I only restrict the graph to this little portion and erase everything else, right? If I erase everything else, but I keep this, then if I draw a horizontal line, it will only cross it once. Okay. And this would be a one-to-one function. Okay. All right. So what happens here is we restrict the domain. Okay. So for y equals sine x, we restrict it for x in between -pi/2 and pi/2. And for cosine, we restrict the domain for x's in 0 to pi. Okay, so we see here cosine will be restricted to this piece of graph, which makes it one-to-one. Okay, and this piece of graph goes from 0 to pi. And sine graph is restricted to just this piece right here. This piece is from -pi/2 to pi/2. Okay, so that's what we're seeing right over here. Okay, and then when we look at tangent, tangent gets restricted as well, and it's going to get restricted for x's, and we're not going to include the endpoints because if you remember, the endpoints have asymptotes, so it will be from negative pi over 2 to pi over 2, and we do not include the negative pi over 2 and pi over 2. Okay. All right. You know what? I'm going to stop there, and then I'm going to take a look at each of the inverse trig functions. Okay, so let's stop there, and we'll do this in, I guess maybe we'll do it in three separate videos. Okay.